Welcome guys back again to another video. So in this video we are going to talk about the synthesis of malonyl coenzyme A using acetyl coenzyme A. This is a very small reaction and very small mechanism, but a very important. So normally in biological systems, there are no much acids, bases like sodium hydroxide, potassium hydroxides. There are not there are no much work based on these things, right? Sodium hydroxide, they are not much effective on our biological systems, but most effective ones are the enzymes. So in this process, in this malonyl coenzyme synthesis process, the biotin enzyme, here we have biotin enzyme. This is the enzyme which act as a uh, fundamental molecule or to drive our mechanism towards our final product as malonyl coenzyme A. So let's see what's happened over here. So here we have a mixed anhydride. So I'm not going to talk about the synthesis of this anhydride. I maybe talk about it in another separate video. So for this video, let's start with this anhydride. So when this anhydride and our biotin enzyme mix together, right, a reaction will be formed between these two. What happens is, here in this nitrogen molecule there's a lone pair. This lone pair will be attached to our carbonyl center. So basically the Claisen reaction would form here, right? I hope you know about the Claisen reaction. If you are not familiar with it, I highly recommend you to watch our previous video about the Claisen reaction. It's very important to our whole biosynthesis processes. So in here, when this nitrogen lone pair attacks our carbonyl center, this Claisen reaction would be proceed. So what happens in the Claisen reaction, I hope you know. I will not talk the mechanism in here. In Claisen reaction, this will be acted as the leaving group. So a bond will be broken from here. So with the reaction, a phosphate group, right? Yeah, a phosphate group will be removed from this. So there are hydrogens and bases acting as proton acceptors. And the main thing is, right, this component over here, this carboxylic part here, you can see COOH, it will be connected to our biotin enzyme. So let me take the white color for this. So here we have our product. So this product we call as N-carboxyl biotin enzyme. Right? Okay. So I hope up to this point you are clear. So now what happens is, now we have acetyl coenzyme A. So our main goal is to form the malonyl coenzyme A. What is our precursors? The acetyl coenzyme is a main precursor. So now we have the acetyl coenzyme A. I hope you know the structure of acetyl coenzyme A. So here coenzyme A. So here we have the enzyme part, right? CH3. This is our acetyl coenzyme A. So this carbon over here, this is the alpha carbon. So its hydrogen has acidic properties. So with the current base, with a biological base, we can convert this as into an ionic form like this. So now what happens is, we have our biotin enzyme. So this is our biotin enzyme which is connected to our carboxylic group, right? I didn't draw the whole structure of the biotin enzyme. So this is basically this white structure, right? I just put a circle for the white structure. So now what happens is, look at this. Here you have a nucleophile. Here you have a carboxylic group. You have a carboxylic group which is a carbonyl center, So this will go and attack to our carbonyl center. Again, a Claisen reaction would be formed, right? You know what happens in the Claisen reaction. So this will be acted as a leaving group. So with this reaction, this will be removed. Our product will be formed as so this is called as malonyl coenzyme A. So let me take the acetyl coenzyme A also for here. Here we have this acetyl coenzyme A. I just use these two molecules for comparison, right? This is acetyl coenzyme A. So look at the main difference of these two is the acidity, right? So here look at this one. So here we have the alpha carbon over here. Here we have the alpha carbon over here. If I ask you what is the most acidic hydrogen from these two molecules, you would choose this one, because this carbon over here is in between two carbons. So these hydrogens has much higher acidity than the acetyl coenzyme. This is very essential in our complex molecules when it comes to the biosynthesis. So just take an idea, just have an idea about it. So this is basically the synthesis of malonyl coenzyme A using acetyl coenzyme A. I hope you get the idea. So in next video we will go into more complex reactions and more complex metabolites. I hope you have a good day.